Okay, in this video, we're going to talk about graphing secant and cosecant, which secant is a reciprocal of cosine and cosecant is a reciprocal of sine. So first, let's go over that real quick. It's a little confusing. I always think of like the first letters never match up. So if you have sine, cosine, and tangent, all right, the reciprocal of tangent is cotangent, which makes sense. Just put angles here because they have the word tangent in them. So they're cofunctions and reciprocals. And the first letters don't match up. So like the T and the C are different. All right. Now, if you keep that in mind, then the reciprocal of sine is going to be cosecant because the first letters don't match up. So like S and C, they have different first letters. And then cosine and secant are reciprocals. So when we graph cosecant, we're going to set it up just like sine. And when we graph secant, we're going to set it up just like cosine. And then the last step is the only thing that's different. So let's set this up like we're graphing sine. So, or cosine rather. So for number one, we're going to graph y equals 2 times the secant, 3x minus pi over 2 plus 1. So the first thing I do, even though it's not the first thing on this list, is I'm going to, let me zoom in a little bit. I'm going to find the starting point. So the starting point, no matter what you're graphing, is going to occur at the x value that makes whatever's inside the parentheses equal to 0. I think that's the easiest way to remember it. Instead of trying to memorize a formula, I just take that expression inside the parentheses and set it equal to 0 and then solve. Because you want to figure out what x value will make you take the cosine of 0 or the secant of 0 or the sine of 0, tangent of 0, cotangent of 0. Because anytime you take the sine, cosine, tangent, blah, blah, blah of 0, it's going to be a nice, easy ratio, like 1 or 0 or undefined. Same thing with multiples with the quadrantal angles. If you choose an x value that makes something inside the parenthesis like a multiple of 90, like pi over 2 or pi, you'll get a nice number like 1, 0, -1. And then these numbers here will change it to be a different whole number. But we like to graph whole numbers because if you plugged in other values, then you would have, you'd be plotting points like 3 root 2 over 2 plus 1, which is a really ugly number to plot, and you need a calculator to approximate that as a decimal. All right, so let's solve for 0 here. So if we add pi over 2 to both sides, and then divide both sides by 3 or multiply both sides by 1/3, then we get x is equal to pi over 6. All right, so that's going to be our starting point. So our starting point is going to be x is equal to pi over 6. And then before we set that up on our axes, I'm going to find the period. So period for sine, cosine, and their reciprocals, secant and cosecant, is always going to be 2 pi over b. So if b is 3, it's going to be 2 pi over 3. All right, so that's our period. And we can fill that in right here, 2 pi divided by 3. And our increment, no matter what we're graphing, is going to be 1/4 of our period. Because like what I was mentioning earlier about the quadrantal angles, like if you take a trig function of 0, 90, 180, 270, 360, any of those angles that are multiples of 90, you're going to get nice ratios like 1, -1, 0. And that's why we do that. That's why we start at 0 and we divide our period by 4. So if we take 2 pi over 3 and divide it by 4, that's the same thing as multiplying by 1/4. So that comes out to be 2 pi over 12, which reduces to pi over 6. So that's our increment, and that's the same thing as our starting point. So that's nice and friendly. If they were different or if they had different denominators, I would suggest that you get a common denominator. So we'll go over an example like that later. All right, so that means we're going to start at pi over 6. Oops. And we're going to plot a point every pi over 6. All right. Our sinusoidal axis, or our midline, is going to be y equals 1. B is 3. We already accounted for that in our period earlier. And amplitude is 2. So now we have all the information that we need to set up our x and y axes. So we're going to start right here at pi over 6. And then every point we're going to plot is going to be pi over 6 horizontally from the other point. So if we just keep adding pi over 6, this would be 2 pi over 6. All right, this would be 3 pi over 6. This would be 4 pi over 6. Now, I'm a man who likes to simplify. I don't know about you guys. Oh, this is a 3. This should be a 6. I'm going to simplify these. So 2 pi over 6. So pi over 6 with pi over 6 is 2 pi over 6. That reduces to 3 pi over 6. And then, pi over 3. And then this would be 3 pi over 6, which reduces to pi over 2. Then this would be 4 pi over 6, which reduces to 2 pi over 3. All right. And then if you go backwards, so pi over 6 minus pi over 6 is 0. Subtract another pi over 6, that's negative pi over 6. Subtract another pi over 6, that's negative 2 pi over 6, which is negative pi over 3. Negative 3 pi over 6, which is negative pi over 2. All right, and you get the picture. And you don't have to plot every single increment, but do at least like 3 of them so the person can tell, what the increments are. And you should always have the same distance between your tick marks. You don't want this to vary here. All right, now for our y-axis, we're going to look at our midline, which is at y equals 1. So we got a nice horizontal line here to y equals 1. It's not actually part of our graph, but we use it as like a guide for points. And the amplitude is 2. So our max is going to be at 3, which is 2 units above 1. And our min is going to be at negative 1, which is 1 unit below, which is 2 units below 1. So that's at negative 1. Okay, so now we're going to plot our points. And right now, this has been the same exact setup as sine and cosine. And it's going to continue to be that way for this next step. So remember, secant of x is equal to 1 over the cosine of x. So therefore, I'm going to plot the following points as if I'm graphing the cosine. So y equals 2 times the cosine of 3x minus pi over 2 plus 1. So I got everything set up for that. So we're going to start at pi over 6. And because it's the reciprocal of cosine, we're going to start at the maximum. All right. If there was a negative in front of our equation, then we would reflect that over the sinusoidal axis, and we would start here. Right? But that's not the case. So we start there. All right, and then cosine starts at the max and then decreases. So our next point, so we go over an increment, down an amplitude. Over an increment, down an amplitude. Now we're at our minimum, so we're going to work our way back up. And that right there would be 1 full period. And if we keep working in the other direction, we could go left to increment, down an amplitude. Oops. Left an increment, down an amplitude. Left an increment, up an amplitude. Left, up, left, down. Okay, so at this point, we have done all the steps for graphing this. Y equals 2 times the cosine of 3x minus pi over 2 plus 1. So if we were graphing this cosine, it would look like this, and we would be done. Now we're not, so we're going to graph secant. And here's the difference. All right, secant is the reciprocal of cosine. So if we didn't shift this at all, like this would be our maximum, this would be at 1. And 1 has a reciprocal of 1. Same thing down here. These minimums are negative 1 before you apply like the 2 and the 3 and the pi over 2 and the 1. So if we're just graphing the parent function, the max and the min would be at 1 and negative 1. So the reason why I say that is because now we're finding the reciprocal of that. And the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. So our max and min wouldn't change. But our points on the sinusoidal axis, if that wasn't shifted up or down, all right, and you do that after you evaluate the secant of the angle, all right, those would be on the x-axis, which is 0. Now, the thing about 0 is the reciprocal of 0, like 0 over 1. If you flip it, it becomes 1 over 0, which is undefined. So when you're graphing secant, any point on the sinusoidal axis is going to now become, you're going to draw a vertical asymptote through that point. So that's the only major difference here. Well, there's 2, and it's coming up. I haven't talked about it yet. So when you're graphing secant, you set it up just like cosine, but once you have your points plotted, wherever there is a point on the midline of the sinusoidal axis, you draw a vertical asymptote. Okay? And then, last but not least, is instead of decreasing here, all right, it's the reciprocal of cosine. So like, let's say you had like 1/2. If you found the reciprocal of that, it would become 2/1. So where these numbers are decreasing, getting closer to 0, if we're actually doing the reciprocal, they're going to actually approach infinity. So what you do is, for every maximum, you draw sort of like an upward facing parabola. And for every minimum, you draw a downward one. And that's how you graph secant. All right. So everything in black, other than those vertical asymptotes, which I'll highlight in blue, is the same exact setup as cosine. So if you can graph cosine, you could pretty much graph secant. The only difference is every other point on the midline, you draw a vertical asymptote. Every point on the max, you draw upward facing parabola. Every point on the minimum, you do a downward facing parabola. All right, so before we go on to the next example, which would be a cosecant, does anyone have any questions? All right, no questions. So let's try the next one. Okay, so now let's graph negative cosecant of x minus pi over 4 plus 3. So starting from the top this time, our amplitude is going to be 1. Now I know it's -1, but technically an amplitude is a distance, so I like to always make it positive. But this negative will affect our graph. It's going to reflect it over the sinusoidal axis, so we have to keep that in mind, that there is a reflection. All right, b is also 1 because the number in front of x is 1. All right, remember, this is like our parent function, or not our parent function, but this is like what a, b, and c represent. All right, so a is the number in front of cosecant, b is the number in front of x, c is what you subtract from b of x, and d is what you add to the end. All right, so period is going to be 2 pi, because period is 2 pi over b, because the period of sine is 2 pi over b, so cosecant is not going to change because it's the same ratio, it's just flipped. All right, so that means the increment is going to be pi over 2, because that's 1/4 of pi. All right, so that's period over 4. The sinusoidal axis is at 3. And the starting point, what we're going to do is we're going to take the expression inside of the parentheses and set it equal to 0. And we get x is pi over 4. So that's our starting point. Now, don't always assume it's this number, because if there's a number in front of x that's not 1, that will affect the starting point. Because remember, that number in front of x is going to horizontally stretch or compress our graph, which could move our starting point. All right, so technically, the starting point is always going to be c over b. Because if you think about it, if we have bx minus c inside the parentheses, and we set it equal to 0, and we divide, and we get b alone, all right, our starting point, if you want to think of it this way, is always going to be c over b. But I don't like to memorize formulas. I like to think of things so that I don't have to memorize, because I'm bad at memorizing things. So I always just take the expression inside and set equal to 0 and solve. All right, so now we have a little difference here between our starting point and our increment, which is okay. All right, all we're going to do is, and you always want to do this, at least I suggest it to make your life easier, is to get a common denominator between your increment and your starting point. So the starting point is pi over 4, the increment is pi over 2, so I'm going to rewrite that as 2 pi over 4 by doubling the numerator and the denominator. All right, so why is that important? Well, now I could make every tick mark be pi over 4. So this could be pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi. All right, so this would be negative pi over 4, negative 2 pi over 4, which is negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, which is negative pi. All right, so every increment, not increment as in this number, but every distance between my tick marks is going to be pi over 4, which means since my increment is 2 pi over 4, I'm going to plot a point every 2 dots. All right, now I'm just placing those randomly right now, but just so you can see how I do this. All right, so now we're going to start. Well, now we have to set up our y-axis. So our midline is going to be right here at y equals 3. And since our amplitude is 1, we're going to go up 1, so up to 4, and down 1 to 2. Did I not 1, 2? Oh, silly me. Right there, 2. Okay. So now we plot our points, and we're going to plot it just like we're graphing sine here. So we're going to start at pi over 4. And we're going to start on the midline because cosecant is the reciprocal of sine. So we're going to plot these dots just like their sine. All right. Now, if we were graphing sine, we would go down now because there's a negative leading coefficient, which means everything gets reflected. So we're going to move over an increment. Remember, our increment was 2 pi over 4. So we're going to go over 1, 2. And then since there's a reflection, we're going to go down 1. And we're going to plot that point right there. And then go over an increment, so 2 tick marks. So that's 2 pi over 4. And then back up to the midline. And if we reverse course here from our starting point, we go over 2 increments, then up the amplitude. Go over 2 increments, and then we're here. Go over 2 increments, and then we're there. All right, so now this isn't quite 2 periods. If you needed to graph 2 full periods, you would have to, either just graph it a little farther to the right, but I kind of ran out of room. So we're just going to graph like a little over 1 period here. And now since it's cosecant, anywhere where you have a point on the midline, just like secant, you're going to graph a vertical asymptote. Because remember, the reciprocal of 0 is 0. And at these points on the midline is where the sine of these angles would equal 0. So the cosecant is going to be 1 over 0, which is undefined. Then, wherever there's a maximum, we're going to draw like an upward facing parabola. And wherever there's a minimum, we're going to draw a downward facing parabola. And that right there is about 1.5 periods of cosecant. And if you needed help graphing sine, well, let's quickly, since we have everything set up, let's see what y equals negative the sine of x minus pi over 4 plus 3 would look like. All right, so this is very similar to this. The only difference is cosecant versus sine. But if everything else is the same, if I was graphing sine in red, it would just look like this. So sometimes you can actually just graph sine first as like a guide, and then just add these parts at the end if you're doing cosecant. All right, but ultimately, if you're doing cosecant, all you have to do is what's in black here. And that's it. And that's all I need to do. And then let's talk about domain real quick. So domain wouldn't be all real numbers because you have these restrictions here. So if you find one of them, so the domain, well, what can we do is a different color because I don't want to get confused with sine here. All right, if I said, what's the domain of cosecant? Well, it could be any real number except x can't equal pi over 4. And then it repeats every 1, 2, 3, 4 increments, which is pi over 2. Hold on real quick. Pi over 4, 1, 2, 3, 4. So every tick mark is pi over 4. So it's 4 times pi over 4. So this distance right here is pi. So like every pi horizontally, we're going to be on an asymptote. So pi over 4 plus pi times k, where k is an integer, would be how you'd write your domain because it repeats every whole pi. Every time you add pi, you're going to be landing on an asymptote, which is where x can equal. And then if I was doing the range, which doesn't ask you to do it here, but we could just talk about it. Well, we look and right here we see that, well, y could be less than or equal to 2 because it hits every point on the y-axis below 2. Or it could be greater than or equal to 4 because it hits every point above 4 on the y-axis. So that would be your range. So pretty much nothing in between 2 and 4, but everything outside of that. All right, that's how you graph cosecant. All right, and now you could go and finish these problems, and I'll help you if you need help. But it's going to be the same exact setup. And if it's sine or cosine, then you draw that middle like curve. If it's secant or cosecant, you do the parabolas facing opposite directions.